Hello everyone. I'm very happy to be here at the SolarPunk Conference 2023. My name is Enrique Sanchez and I will be presenting Seeding Tomorrow, Sustainable Hydroponics and Open Source Technology Blueprints. The first half of the presentation will be an introduction to hydroponics and my experience with sustainable hydroponics, and the second half will be about the OikoSol Project in creating technology blueprints. So why hydroponics in the first place? Well, most of hydroponics has been adopted, in fact, because of its many advantages, including water conservation, because the water is recirculated all the time, faster growth due to the supplying of all the nutrients in a plant available form, more control in different plant stages. This is because we have either artificial light or the nutrient solution that allows us to promote certain parts of the plant stage independently. Higher yields. The plant doesn't spend as much energy searching for the nutrients because we provide everything already. Space maximization. It's possible to grow vertically more easily, as you can see in the image. Reduction in labor. In fact, the lack of because it's possible to automate a lot of things: the water movement, the soil, the nutrient dosaging, etc. It's also possible to reduce labor through higher automation, and fewer pests. Because there is no soil, that breaks a little bit the life cycle of potential pests that might come and attack the plants. But there's many different parts about hydroponics, and let's start a little bit first with how soil works as well. So in farming we have soil cultivation, where we typically the most type of soil grown method right now is intensive agriculture, unfortunately. This uses something called the Haber-Bosch process, where we extract nitrogen from the atmosphere and also extract other macro and micronutrients from the soil, from the earth, and then we create artificial fertilizer, and thus we can get a lot of intensive yields from that at the expense of the soil health. On the other hand, we have the more organic, ecological, biological type of agriculture, wherein permaculture falls. There we kind of focus a bit more on creating synergies, on recycling waste from certain processes by using also organic waste or food waste, and then creating that or using that to create some living soil. So there's a bit more of a recycling component. And then we have the soilless aspect, or the hydroponics aspect. And there I would divide in two main parts. First, we would have the most common type of hydroponics, which is mineral hydroponics. And here, a bit like in intensive agriculture, we also mine the NPK fertilizers for this type of growing. So we extract non-renewable minerals from the earth to create the nutrient solutions that then we feed to the plants. And then we have the other main type, which would be organic hydroponics, which can further be divided in three other types. One would be aquaponics. I will talk a little bit more, but basically we are growing fish and plants simultaneously, and this is the biggest type of organic hydroponics that is practiced. However, the actual source of the nutrients comes directly or indirectly from fishing, to create the fish feed for the fish, which then will supply the rest of the nutrients for the plants. Still within organic hydroponics, we have bioponics. Here it's a bit similar to the organic, ecological, biological agriculture. We're also trying to use waste streams from something else, could be organic waste or just food waste, to recycle them until they reach a plant available form, the nutrients, so the plants can uptake them. But all of this is done in a soilless environment. And finally, we have anthroponics, anthro here meaning derived from humans, where we try to also recycle waste, but this time it's human waste, so it will be type 1 or type 2 human waste for that purpose. All right, let's get a little bit more into each one of these. So with mineral hydroponics, the most common type that is practiced is active mineral hydroponics. So active here means that you are supplying some sort of energy to run the whole system. But before that, I should say, every time I talk to someone and introduce them the concept of hydroponics, the first thing they ask me is, how can the plants even grow when their roots are completely submerged in water? This is because in their experience, when they grow with soil, if you overwater a little bit too much, you kill the plants. Well, actually, we can do this here because we are taking into account this very factor. When you overwater your plant with soil, you create an environment that is low in oxygen, which can develop certain fungi or bacteria that can attach to the roots of the plants and therefore asphyxiating the plants or preventing the plants from absorbing the nutrients. In most types of hydroponics, we try to fight this in some sense. So that's why it is possible, in fact, to grow plants, and a lot of plants, with their roots completely submerged in water. But anyway, how it works in practice is you set up your system. Here you can see a window garden that I built some years ago. Then you will purchase your liquid or solid fertilizer. You will mix it with water to create your nutrient solution, and then you will add it to the system where there is some sort of recirculation of the water and aeration as well. So here in the right image, you can see there is a bottom container where the nutrient solution is added. Then that flows through the top with a water pump, and then flows through the lid, each different pot by gravity, all the way back to the bottom, where we also have an air pump aerating that oxygen to create some oxygen in that environment. So yeah, hydroponics is already fairly sustainable in terms of water usage, especially because the water is recirculated and reused as much as possible. But however, that was not enough for many people, myself included. So we started developing what is called passive mineral hydroponics. And here the most well-known technique is something called the Kratky method. So in a sense, it works the same as the previous method, but we don't recirculate the water and we don't add any active aeration. Instead, we prepare the full nutrient solution, and as the plant consumes it, the water level drops, and this helps the plant develop something called air roots, which help prevent the root rot that I mentioned before. And in both cases, active and passive, it's very easy to grow vertically and thus be more productive in space usage. So you can see here I have a shelf on the right image where I can grow vertically and thus get a lot of yield in a very small and cramped environment. And even to push things even further in terms of trying to be as sustainable as possible, by reusing existing containers such as bottles, some bottle waste, you can further lower the carbon footprint of the whole procedure. So here you can see me growing chard in Tetra Pak, mint in an Absolute vodka bottle, bell pepper and cherry tomato in soda bottles, as well as basil, and even going further as to build my own do-it-yourself shelf where I grew a lot of lettuce with wine bottles. However, the problem still persists that the mineral fertilizer itself that is used both in active and in passive mineral hydroponics is highly unsustainable. And that's what prompted a lot of people to further look into organic hydroponics. And here I would start with introducing how aquaponics kind of works. So here you can kind of see the nitrogen cycle, which is what mostly powers the aquaponic system. And aquaponics is basically a constructed ecosystem that we built, where we manage 3 different life forms: the fish, the plants, and the beneficial bacteria that help process the fish waste to plant fertilizer. So the fish are fed, and through their metabolism, they excrete waste, which is transformed by bacteria to plant-available nutrients. And then the plants will filter the water, which then returns to the fish. However, as such, we always need constant recirculation and aeration because both the fish and the bacteria require oxygen. And as I've already mentioned, the fish feed does originate from motions either directly or indirectly, which makes the system somewhat unsustainable. There are advances in land-based fish feed or in using waste from other processes, but it's still not ideal in terms of a balanced diet. And this is really where I actually began my journey in hydroponics in general through aquaponics. So I did my thesis in 2014, where it was focused on aquaponics and a little bit of anthroponics, which I will talk soon. But we started by building, me and my coordinator, some indoor system. As you can see here, this is what's called a media bed system. So we have the fish tank in the bottom. The water is pumped to the top, where there is a media bed with some material like light expanded clay aggregates or lava gravel. Here also hosts the beneficial bacteria, and this material also supports the plant root structure. And then in that area, the fish waste gets converted to plant-available fertilizer through the nitrogen cycle. The plants clean the water, and the water returns to the fish. So very simple. We also built a different system that uses different types of hydroponic techniques. And here we decouple a little bit the location of the beneficial bacteria. So from the fish tank, the water is pumped to what's called a biofilter, where the beneficial bacteria are located. And from then, the water will flow to a pipe system, what we call a nutrient film technique, where we have some plants growing. And then to a second system, productive system, where we have a flat a raft that is floating in water. This is called a deep water culture hydroponic technique. And it's also possible to create systems like these in a very small scale. So here you can see a system that I have in my apartment. Even though this was a very productive system, you do lose a little bit the ability to grow edible fish because of the shrinking of the size. So here I used some tropical fish, for example, but it was still a very productive system. And eventually I also entered the commercial aquaponics a little bit, so I helped dimension, design, build, and operate Sweden's first CSA vertical indoor aquaponics system prototype. As you can see here, this was a system that was built in an office space and could produce fresh vegetables and leafy greens and herbs year-round, basically. CSA here meaning community-supported agriculture, so this meant we would sell directly to customers, but I will show you a little bit about that later. And as you can see, this is a very productive system, and we are also using vertical to, again, have a lot of production in a very small space. On the top right, you can see me doing some water tests. And again, very, very productive system. So we were able to grow lettuce, chard, pak choi, basil, oregano, sage, parsley, coriander, cabbage, spinach, chives. And these were very productive systems, more sustainable than hydroponics, also because of the water reuse is even better in these types of systems. However, you do require a little bit more of energy usage in its daily operation because of the pumps that need to move the water from the fish to the plants, which have to pump it to the top of the towers and then flow down, and other instruments that we had to use for that. So as time went on, I became more interested also in anthroponics. And this is still from my thesis. It looks a bit complicated, but I will explain it very briefly. But the main idea is we took the same design principles from aquaponics, but we skipped the fish, instead focusing solely on managing the plants and the beneficial bacteria. So here you can see that there is a low point of the system where we add, in this case, aged human urine, and that would then be pumped to different components of the system. On the right side, you have, again, like a media bed type of system, and on the left, you have a raft system. And above both, you have some towers. So there was water usage going through and some active aeration and all of these. And this was an extremely productive system again. We were growing leafy greens, herbs, tomatoes, cucumbers, and strawberries, just to name a few things. So we were combining different parts, different learnings from hydroponics and aquaponics, and all of this was powered by processed human urine. So after my thesis, I started doing some more hobby-level experiments in an organization that I was a part of, and writing some technical reports. And I did this using these different formats. So you can see here we have 3 parallel systems. Again, a media bed type of system. There is a place in the bottom where we add the aged urine, and then that pumps to the top continuously through a water pump, where there is a media bed that hosts the beneficial bacteria and the plants, and then the water returns to the bottom. And in these different experiments, I did many, but I will only talk about a few of them. The key result in this one, which was the first main one we did, we know already that on average an adult human produces around 1.4 liters of urine in just one day. And it is estimated that from these results that we had in this trial, one human could produce almost 3 kilos of lettuce from the volume of the urine they excrete every single day. So that is a lot of lettuce. We further refined some of the designs here. We had what's called the nutrient film technique, so growing in a bit of a pipe system. But we have the beneficial bacteria in this separate container with a moving bed biofilm reactor. And this it's moving just through the use of an air pump and through the use of a clever airlift system. And just by that one air pump, as we are moving the material that is carrying the beneficial bacteria, we also force some of the water to go to the top of this channel and have a constant stream of a film of water go through the roots of the plants. So we were able to be very efficient with our use of energy in this sense. Some further tests we do was to decouple a little bit where the beneficial bacteria are and where the plants are. So here briefly you can see that we have the place with the moving bed biofilm reactor where we had the aged urine, and then once a week we would pump the water to the deep water culture section where the plants would be, where we also have an air pump and an air stone. This system was a bit more energy intensive, but the concept that we could separate things and just add, instead of having a constant recirculation that you would just add occasionally once a week the water, then that worked pretty well as well. Then we started doing again some further research in this sense in bioponics, and bioponics here means that we can use many different types of waste streams to produce some sort of liquid fertilizer that we then mix with water to create our nutrient solution. And again, here we were using the media bed concept. So, and the nutrient source in this sense came from vermicomposting. So vermicomposting is when you add food waste or organic waste and you have some worms that will produce that into some sort of soil that is very rich in nutrients. As a byproduct, there is a leachate, a certain liquid that is produced through the worms and the water that is in the waste that we add. And that leachate we used to add in the system, and through the use of also correcting the pH as well, we were able to grow a lot of things. Some further experiments that we did in Sweden where I am located, a lot of the organic waste or park waste and even food waste goes to produce biogas, which is a very powerful fuel. And as a byproduct, they have something called the biogas slurry. So in this sense, the one we got access to some of that that was coming from green waste, so from parks and things like that. And we were able to successfully grow again, combining a little bit with our moving bed bioreactor, so separating the beneficial bacteria from the plants directly, but we were able to have very productive systems, as you can see. And some further experiments. Here we went a little bit back to the concept of the vermicompost. So instead of just using the leachate, we thought, let's take this vermicompost, taking away the worms from it. Let's heat it up so we dry it, and then we crush it to a very fine powder. And let's add that to the water as the sole nutrient source. So in the left, that was the technical report that I did, where we were able to grow basil in this sense. But here we used also the air pump to mix everything a little bit, because we weren't sure what sort of bacteria we need to develop or what sort of aerobic processes we need to use. But then when I repeated that process by myself in my old apartment, I had one tray with the oxygen and one tray without, and I was able to grow radishes without any active aeration, which was a bit of a groundbreaking moment for me, because I realized we can do organic hydroponics without the use of active aeration. So we still use a little bit of energy, obviously, to process the vermicompost, to heat it up and to crush it. But still, these are things that can be done naturally with the sunlight. So this was very promising research. And more recently, I've been trying to combine a little bit of everything, of all the different researches and experiments that I've done, and sort of think, how can we create some sort of recipe where we can combine the different aspects, so maybe urine or vermicompost leachate, or maybe something called bokashi leachate from bokashi composting, or wood ash, and then by controlling the pH through phosphoric acid or some lime, we can create something that could be used to grow all different types of crops. So something I would call bioanthroponics, perhaps. And on the bottom right was an experiment where I did just that. So I created this recipe in a biofilter. So I added the different components, and the water is recirculating there, creating some oxygen for the bacteria. But then I added that in a passive way to these bottom right systems that you can see. So I was able to grow passively, in a sense, basil, and then make pesto from it, which was a very good thing. So yeah, that was the first half of my presentation about hydroponics. Now let's move on to my other project, which is OikoSol. So OikoSol, I also started around 2014, and I would like to read for you the mission statement. We believe in the development of affordable, decentralized, sustainable technologies to enable ourselves and other interested individuals worldwide to gain more control and independence in their manufacturing power, their energy source, their food and water source, and in their waste and wastewater treatment. Such control and independence is necessary as we believe in the right to self-sufficiency, regardless of its consequences to existing power structures and distribution networks. We believe that only when every individual has fulfilled their basic physical needs can they be free to peacefully cooperate with others from a position of equal power. We aim to create a repository of knowledge of localized sustainable technology where everyone is welcome to spread, debate, criticize, and improve on sustainable home technologies of this OikoSol repository. The end goal will be to provide free do-it-yourself instructions that allow for most individuals or families living in houses or apartments to become as much energy, food and water, waste and transport independent as possible. The technologies in these instructions should be as conducive to life overall as possible, as well as affordable for all individuals globally. So we had this vision, right? Or I should say I had this vision. People only joined me a bit later on to focus mostly on 5 categories: food, water, energy, waste, and transport, and then think about what different technologies we could make that could fit in apartments more or less and that people could build themselves, this meaning they would not be very complicated in a way, and then how do they connect so that people could become a bit more self-reliant. Obviously, I come a bit more from the waste treatment aspect and the food cultivation aspect, so I focused a bit more on that. I was also thinking about using wind energy, solar energy, harvesting rainwater, etc. So in the beginning, I was able to, in the first few years, in 2015-16, I was able to make these first 3 proof of concept instructions. So the media bed aquaponics, a passive hydroponics, and a vermicomposter, which I actually built myself and I use a lot with great success, as well as the passive hydroponics. So again, these are, you have more or less the material list. I try to design it so as to be as simple as possible with as little text as possible, a bit more showing than doing. So as you can see here, trying to show how to cut, how to measure, what to do next, how to move things around. And then in the end of the instruction, you have some recommended reading, or maybe if you've done, if you've encountered some issues, you can say these are the known issues, so that someone that wants to further expand on this instruction can then think about these issues and how they can improve it. And the vision initially, I did have a website. So the idea is you arrive at the website and you say, I want to create my own energy, or I want to recover my own nutrient waste, or I want to grow my own food. You could click that button, and then you would get the different types of technologies that you could choose from and further reading. However, the website was attacked by a botnet a few years ago. So instead, the content now is backed up on the GitHub. But the plan is again to release our website again, maybe also with some rebranding, and to have things a little bit more easy than to use on the GitHub. And to organize all of this, initially I had a Trello board where I would think about all my different ideas, all the research for the different technologies, and then try to follow up on each one on the different experiments. But instead now I've moved to Discord, and I invite everybody of you to join the Discord. We are 30 members, a bit more over 30 members now. But again, if you just like to talk about the concept, you're welcome. If you want to read more about the different technologies and what's possible, you're also welcome. If you want to show some of your own testing that you might want to do, or to help other people do some testing, you're also welcome. But more importantly, what we really want to do is to create the instructions so other people can build these things. So that's really my call to you. If you want to join, you can check the QR code here, or join the link, or check the description of this video. Really, we need help with creating the instructions. We already have a lot of technologies ready to go. We just need help to create these instructions so that people can start testing them and improving on them and creating alternatives as well. So that's basically my presentation. I just have a few final remarks because I presented many practical ways in which we can use low-tech solutions to deal with our predicament. Even though I do not believe in magical technological solutions to fix our problems, such as climate change or our energy thirst, I think it's useful to start thinking of how our future technology can benefit from our present scientific knowledge, our reuse of materials, our mimicry of nature, as well as the knowledge of the difficult times we expect to experience ahead. In regards to our food production specifically, I believe it's important to explore sustainable hydroponics because it's a way to reduce our depletion of soils via intensive farming, also as a way to help us become a little bit more self-sufficient. And finally, there are no panaceas to our problems, but with the inspiration from events such as this SolarPunk conference, the collaboration between all of us, and our collective action, I believe we can mitigate many of the challenges we will face, adapt, survive, and thrive. So thank you for your attention.